Okay, you will notice that the first question with most of them is finances. So don't now take a pen and scratch it out. Next time we're going to do finances. Then you have some questions to work out. So just, you'll see it starts with interest and what. That's not for this term. We didn't do it this term. I want you to open up at November 2018. Question 9. You'll see question 8 is plain and straightforward. 6 red balls, 8 green balls in an unknown bag. The probability, blah, blah, blah. Nothing funny there. You can go and practice it on your own. I'm not going to do it now. I want us to take a look at question 9.1 and 9.2. Now, I taught the Afrikaans class now as well. You must know those equations that we wrote down the other day. I summarized it with you. You must know them so well. Okay. And besides knowing them, you must know which one belongs to which one. Okay, so it doesn't help if you know, oh, there's an equation that's the probability of A or B is the probability of A times or plus the probability of B, but you don't know which one it belongs to. Okay. Another thing you must remember is something can either be inclusive, and if it's not inclusive, you can assume that it's mutually exclusive, and the other way around. Do you understand what I'm saying? Okay. So it can either be the one or the other. Therefore, sometimes it will be easier. Maybe you want to prove something is mutually exclusive, but you have information about inclusive. So then you use inclusive formula. If you've proven that it's inclusive, then you have also proven that it's not mutually exclusive. Okay, the same for dependent and independent. It can just be the one or the other. If it doesn't work for with your equation, then it's the other one. Klaar. Okay. Alright, but 9.1 is a bit tricky. So what we used to, when they ask us whether the events were dependent or independent, is we would have the specific values. Now we just have this contingency table. Okay. The question that they are asking is about the choice of snack on this flight being dependent or independent of gender. Okay. Now, this is not something you go on at all ever, but if you think about it, if the choice is vegetarian and it's chicken, do you think it does depend or does it not depend on whether it's male or female? Do you think there are more females or less in comparison with males that would choose chicken or vegetarian? I think so. You'd rather find maybe a woman that will be eating vegetarian than a man. No? So I think maybe it can be, it is a possibility that it is dependent on each other. Okay, but that doesn't matter. We have to calculate it. Now, do you know what the formula is for dependent or independent? Now, I want you to open your book there where we wrote down those equations. We've got the equation for dependent and independent. Can we use dependence formula? What did we write there by dependence formula? What does that mean? Why did we write tree diagram? You can only use it if you've got a tree diagram, because remember that equation says the probability of A times the probability of B followed or following A. So I don't have a tree diagram, so therefore I don't know, I can't use it. Therefore we can use the other formula. Do you know that other formula? What is it? The probability of A and B is equal to? Okay, great. So the event that we have happening here is it can be male and it can choose vegetarian or chicken. It can be female and it can choose vegetarian or chicken. And this is the hard part, what I'm going to explain to you now. You have to choose one. So you have to choose to see whether it's dependent or independent with male and chicken, or male and vegetarian, or female and chicken, or female and vegetarian. Okay, because we need two probabilities. And they are asking, is it dependent with the choice of food and gender? Do you hear? Not the two choices of food, not chicken and vegetarian. Does it depend on whether you are male or female, whether you choose chicken or vegetarian? So for the example, do you want to choose, let's ask Antoinette, male or female? Female. Okay. Moana, before you fall asleep, chicken or vegetarian? Chicken. Okay, so we're going to taste it with female and chicken. Okay. How many people are on this flight? 150. Okay. Now what's the probability? Because we need to get a probability of female and we need to get a probability of chicken, and then we need to get a probability of female and chicken. Do you agree? So that we can test whether the calculation works or not. What's the probability of going onto this flight and choosing a female? 83 over 150. Very good. Do you all understand why it's 83 and why it's 150? Yes. Okay. What is the probability of picking someone that chose chicken on this flight? 118 over 150. What's the probability of choosing someone that's female and that chose chicken? Done. So they are dependent. So what was the hard part? Realizing or trying to figure out what are they asking about. They are asking about a food choice and they are asking about male or female. And that's how you had to choose either of the two meals and either of the two genders. But the rest is easy. Eh? Now, obviously you can choose male and vegetarian as well. If you chose male and vegetarian, you ask yourself, how many males are there? Or what's the probability of choosing a male on the flight? What's the probability of choosing vegetarian? A person that's vegetarian. 32 over 150. What's the probability of someone being male and a vegetarian? No, vegetarian is 12. Are these two equal to each other? No. So they are dependent. Done. Okay, when you are done copying, I want you to quickly try 9.2 yourself. Try it yourself. So they are saying for any two events A and B, it is given that the probability of A and B, that's telling you something, ne? A and B is equal to 0.12. The probability of A or B is equal to 0.83. And the probability of B is equal to 4 times the probability of A. Are the events A and B mutually exclusive? Justify your answer. So mutually exclusive, the formula that we know about a lot, ne, is that the probability of the one plus the probability of the other gives you the probability of all. Ne? because it doesn't cut. But go and look at that page where we started with probability in your textbook. No? Well, I'm not sure. Let me check what page it is. All of the formulas are there. Go and see if there's one that you can use, and if you find it, you can add it to the summary that we wrote there with the probability. Here they are. Page 247. Okay, can we start looking at it? Alright, the first question, 9.2.1, are events A and B mutually exclusive? Justify your answers. So, if you tried the equation for mutually exclusive, you needed the probability of A and you needed the probability of B. So, it didn't work, ne? Okay. If you wanted to use the inclusive equation, you couldn't use that either because it also needs the probability of A plus the probability of B. But on that page 247, look at that formula for mutually exclusive. They give you the formula and then just if you read a bit further, it says or, and then it says the probability of A and B equal to 0. That's also an equation. Okay. So you should add that to your summary as well of mutually exclusive. So when it's mutually exclusive, it means that it says that the probability of A and B is equal to 0. Do we have the probability of A and B? And what is it? 0, 1, 2. So is it 0? No, so therefore it's not mutually exclusive. How easy was that? Okay, so we say at 9.2.1, the first answer, you say the probability of A and B equal to 0, but the probability of A and B is 0, 1, so therefore it's not equal to 0, and therefore not mutually exclusive. It's so easy, we are trying to make it hard. No. The second one is calculate the probability of B. Who wants to try and give us a equation that we can use to calculate B? Let's just look at what we have. We have a value for or, we have a value for and we have some sort of something there for B and A. We have information, but we don't have their values. What equation do you think we should use? What equation has definitely got B in it, it's got and in it, and it's got or in it? Inclusive, no? And this, we just said this thing is not mutually exclusive. So therefore, when I started, I said, when you've proven something is not this, then you can assume it's the other. So this thing is mutually exclusive. So that formula looks like this. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. You know that one? Okay, so I have or, it's 0,83. I have and, it's 0,12. I don't have A and B, but I know that B is 4 times A. So what is A? What is A? No, B is 4 times A. A, if I were to ask you now, give me the value of A. What? Do you know? Do you know what the probability of A is? So what is it? Unknown, ne? What do we put there if it's unknown? And then what will B be? 4 eggs. That's right. When something is unknown, you call it eggs. Right, then you get 5x on this side and you get 0,95 on that side. When you divide, you get x equal to 0,19. Now the question was to calculate the probability of B. Now x is A, no? So this is probability of A, so therefore the probability of B will just be 0,19 times 4 times 4, and that gives me 0,76. Now I've got everything. That wasn't hard, ne? All you had to do was know what you don't know and call it x. Okay, calculate not A. Who has a plan for me to calculate not A? Nongeba? Okay, but what are you saying when you say complementary? Okay, the probability, 1 minus the probability of A will give me the probability of not A. Do I have the probability of A? What's it? 0.19. So the probability of not A is going to be 1 minus the probability of A. So it's 1 minus 0.19, and therefore the answer is 0.81. That's the probability of not getting A. Do you understand? Okay, so now I want you to page to 2017. Take a look at 8.2. They say A and B are two events. The probability that event A will occur is 0.4. Probability that B will occur is 0.3. The probability that either event A or B, you know what or means, will occur is 0.58. Are events A and B mutually exclusive? Okay. Quickly do 8.2.1 and 8.2.2 for me. Just going to go and give a message to another learner. When I come back, I'm doing it. But don't just sit there and make coffee. Look at your formulas. See what you have. They gave you or, they gave you A, and they gave you B. Are they mutually exclusive? Why not? Huh? Why not? What's the equation for mutually exclusive? Okay, so I don't know if I'm imagining it, but everything that you just said was given information on in the question. They gave me or, they gave me A, they gave me B. So I would just use that equation, eh? So or, probability of A or B equal to the probability of A plus the probability of B. That would mean it's mutually exclusive if this is true. Or is 0.58. A is 0,4. B is, what is 0,4 plus 0,3? So is it true? No. Therefore, not mutually exclusive. It's not hard. But if you don't know the equations, it's very hard. Okay. Are events A and B independent? What formula do we need for independent? We can use dependent or independent, but dependent we only can use when we have a tree diagram. So that one's out. So I only have one formula. That's so easy. Probability of A times probability of B is the probability of A and B. So I have the probability of A. I have the probability of B. I don't have the probability of A and B. Can I find the probability of A and B? What is it? Okay, you are right. I thought you were going to throw me with the answer already. Okay, but we will do it nice and thoroughly. Where you know I have that and in the inclusive one, eh? So I just calculated that it's not mutually exclusive, therefore it is inclusive. So the probability of A plus the probability of B minus the probability of A and B. Do you agree with that? Okay. Now the reason I said that I thought you were just going to throw me with the answer is because OR is 0,58. Then that must be everything. And A and B together are 0,7. So don't you agree we can already see that the amount that it's too much, that it's over the OR, is 0,12. You see that? And therefore that will be AND. Do you understand? With mutually exclusive, the probability of A plus the probability of B will give you OR. Okay? But with inclusive, the probability of A plus the probability of B will be more than OR. Ne? So you still have to subtract the AND. Ne? Have you heard of this? No. You must subtract the AND. So what must be subtracted from 0,7 to get 0,58? 0,12. That's how I knew right from the beginning it would be 0,12. I'm just telling you that. But you can use the formal formula 0,58 equal to 0,4 plus 0,3. So there I'm redoing what I did there at the top. No. Now I'm just figuring out what's minus x. So I take x over to this side, and then I've got 0,7 minus 0,58, and that gives me 0,12. This is now the probability of A and B. You guys look a bit unsure about my shortcut. Do you get my shortcut? Sure. Okay. Alright. So back to what the question is actually asking. We calculated A and B so that we can see what's the probability of A times the probability of B and see if it gives me this probability of A and B. So for independent, the probability of A times probability of B equal to the probability of A and B. What's probability of A? Probability of B. Probability of A and B. Okay, and what is 0,4 times 0,3? So what are these? Independent. You can just give the 0,12. You don't even have to show the subtraction. because you did it there, it, I know where you're getting the 0,12. Okay, so you can just say Andy 0,12, 0,4 times 0,3, 0,12, it's independent. Because we need to, you guys see that you are struggling to finish, no? So you must know your work a bit better, so that you go through it smoothly, easily. Okay. Right. Question 9 is Venn diagram that you will be able to draw. You can go and practice that at your own time. Next page, 2016, 9.3. I want you to quickly draw that tree diagram. That's like the snowfall, not snowfall. Okay, I'll read the question with you. Just draw it here on this page, it's fine. The probability that the first answer, okay, so you're starting a test. The probability that the first answer in a math quiz competition will be correct is 0,4. If the first answer is correct, the probability of getting the next answer correct rises to 0,5. If the first answer is wrong, the probability of getting the next answer correct is only 0,3. Draw a tree diagram. Go. Can I draw it? Okay, how many events are there? What are the events? What are the events? What's happening? What's going to happen? You're going to answer a question. Okay, that's the event. Oh, I was hoping you get it right. But I know you get it, eh? Okay. In event number 1, what are the 2 outcomes? Correct or wrong? Okay. In the second event, what are the outcomes? Correct or wrong. And this bottom one is just a repeat, no? Okay. What is the probability of getting the first answer correct? What's the probability of getting it wrong? What's the probability of getting the second answer correct if you got the first one correct? So what will the probability be of getting it wrong? What's the probability of getting it correct when you got the first one wrong? What's the probability of getting it wrong? You got it! Okay. Remember, when you draw a tree diagram for a test, you must just write the outcomes at the end. So you don't have to write the percentages or the probability. Just write CC, CW, WC, WW. You have to write the outcomes. Okay, so the question that they ask is what's the probability of getting the second answer correct? So this first one and the third one is the second question correct. So how will I get the probability for correct? That's 0.2. The probability of wrong correct, that gives 0.18, and then you add the 2, so the probability of getting the second question correct will be 0.32. Are you good? You get it? Okay. You will see there's still another question paper on the next page. You can take your time over the weekend, go and work it out. You guys are writing on next weekend, Monday, am I right? First up, yeah, not, I usually the 19th, that one. But before that you've got cattle tourism and English. So you can learn over the weekend, ne? Go and practice this. The bell is gonna go now. Yes, now. But there's just one thing I want to ask you. You can go and look